first thing we want to understand is how to work with powers of 10. So if we start with 10 to the first power, we know that that's 10. It means 10 times 10.
I mean, it just means 10.
10 to the second power means 10 times 10, which is 100. 10 to the third power means 10 times 10 times 10, which is 1,000. Now, if you think about 10 to the first power, which is 10,
Well, 10 to the 0 can't be 10 because 10 to the first was 10.
when we're going down here, let's say go up from 10 to the third down to 10 squared. Instead of multiplying by 10 each time, what do you think we're doing? Dividing by 10. So we're actually dividing by 10, which gets rid of the 0. So multiplying by 10 increases the 0 in your number. Dividing by 10 decreases the number of zeros in your number by 1. So every time I decrease my exponent by 1, that's the same as dividing by 10. So 10 to the third has 3 zeros. If I go down to 10 squared, it only has 2 zeros because I divided by 10 or took away one of the zeros. Okay? Now if I keep going, so let's get ready to explain to you how to work with zero powers and negative powers. So if I go down to 10 to the 0, I'm going from 10,
And I'm going to divide by 10. And what's 10 divided by 10?
1. So that's why 10 to the 0 power is 1. Because 10 to the first power is 10. So if I go down to 10 to the 0 power, I have to divide the 10 by 10, which gives me 1. Now, if I continue dividing, I end up with 10 to the 0 is 1. And if I divide that by 10, it's the same thing as 1 divided by 10, which is 1/10.
We can write that as a decimal 1/10. So 10 to the negative 1 is the same thing as 1/10,
which equals 0.1. Both of these need 1/10.
if I divide by
10 again, which means now I'm going to have 10 to the negative 7. I now have basically divided by 10 again, which is the same thing as putting a 0 on the 10 that's in the denominator. So I get a 100 in the denominator. So it's just like what I did when I multiplied by 10, only go in the denominator now. So 10 to the negative third is going to have 3 zeros in the denominator. So that's 1 over 1,000, which is
1/1000. And if we write it
as a decimal, that's 0.001.
1 in the thousands place. Multiplying by powers of 10. So we're going to multiply each of these numbers, 1 through 5, by 1,000, 10,000, and a million.
So let's start with number 1. What would 6.415 equal multiplied by 1,000? So we would multiply by 1,000.
Multiplying the number by 1. So for 1a,
We get 6.415 multiplied by 1.
but the 3 zeros are going to move our decimal 3 places to the right.
And then it was 6,415. And then we get the decimal 3 places
To the right. For number 1b, we're multiplying by 10,000. So we multiply the number by 1. We get 6, 4, 1, 5, and then we move the decimal 4 places because there's 4 zeros. 1, 2, 3, 4. So we end up with 64,150. For 1c, we're multiplying by 1 million. So we multiply by 1 to get 6415. And we're going to move the decimal 6 places because there's 6 zeros. 1, 2, 3, 4, 5, 6. So
we'll move it 3 places past the 415, and we have to
add 3 more zeros. So we get 6,415,000. So for
3.00341 times 1,000, we are keeping the number 301 times 1 and moving our decimal 3 places. 1, 2, 3, since there's 3 zeros.
so we end up with
141.
when we multiply
Number 3 times 10,000.
we're going to move the decimal 4 places. 1, 2, 3, 4. So we get 34 and 1/10.
And for number 3C, when we take
0.00341
and
and
multiply by a million, that means we're going to remove the decimal 6 places. 1, 2, 3,
4,
5, 6. So we end up
with 3,410.
when we take 20,000 for number 1 and divide it by 100 for 1A, we're going to get 200 because these 2 zeros will cancel these 2 zeros. So the decimal points out of the way when we divide. So we end up with 200. You can also think of it as a fraction, and these zeros on top of each other cancel each other, so you get 201, which is just 200. We have 20,000 divided by 10,000, we get our decimal 1, 2, 3, 4 places.
So this equals 2. In other words, you have
4 zeros here, so you're getting rid of 4 zeros
there, moving your decimal 4 places.
Here we have 0.2 because we're going to go decimal 6 places. We have 1, 2, 3, 4, 5 places. We have 5 zeros, so we're going to go decimal 1, 2, 3, 4,
5 places.
So we end up with 0.202 times. Alright, so for 3A, we are dividing by 100, so that's 2 zeros.
So we're going to move our decimal 2
places. 1, 2, so we end up becoming 0.013.
For 3B, we're divided by 10,000.
We have 1, 2, 3, 4 zeros, so we're going to move our decimal 4 places, which means 1 place around 1, and then 3 more places. 1, 2, 3, between 4 zeros here.
1, 2, 3. So 1 place around the 1,
And then
4 more places to have 4 places. And then for number 3C, we're dividing by 100,000.
So that's 1, 2, 3, 4, 5 zeros. So we need to move the decimal
5 places, which is really just 1 place around.
1 and then how many more places? 1 place around 5 and then how many more places before turning 5? 4. 1, 2, 3, 4.
Here are the rules for changing from decimal form, which is also called
Standard form to scientific notation. And you will do your questions for science.
as well as right here. So the first thing you need to do is move the decimal so there is only 1 digit to the left of it. So
here I have the number 183 million. Move the decimal
so that there's only 1 number to the left of it.
What number is to the left of my decimal? 1. So does everybody understand what I mean by 1 number to the left of the decimal? 1 number in front of my decimal.
That's the trick. That's really one of the keys to scientific notation is you always have to have 1 number.
0 to the left of the decimal. You know what number you start with, big or small. Then you're going to write it times 10 to some power. And you have to figure out what exponent goes on the 10.
Well, the exponent means
How many zeros there are, right? So you're going to determine the exponent by counting how many places you moved your decimal.
so here I moved my decimal. I wanted it to
Come right here between 1 and 8. So I moved my decimal 1, 2, 3, 4, 5, 6, 7, 8 places. So since I moved my decimal 8 places, that's how I know that my exponent should be an 8. And you drop all your extra zeros. You don't want all these zeros. That's the whole point of scientific notation. You don't have to write all these zeros out.
now big numbers have positive.
Positive exponents and little numbers have negative exponents.
So let's look at a couple of examples.
So 0.0021, this is a little number. It's a number less than 1. That's what I mean by a little number. So if I wanted to write this with scientific notation, the first rule is make sure that there's one number to the left of the decimal. So what would I write? So in this example, we have 0.0021. So we wrote it as
2.1 because we have to have one digit to the left of the decimal.
times 10, and the power was -3 because we would get our decimal 3 places to the right.
In the next problem,
So in this problem, we write 3.405 because we have to have one digit to the left of the decimal, which is 3. We write all the extreme zeros and keep this as living digits, so we'll put letters and 0.4 and 5 matter. It's times 10 to the 6 because we would get a decimal 1, 2, 3, 4, 5, 6 places to the left. And you can also tell that this should be a positive exponent because this really is 3.405 times 10 to the 6 means there's 6 zeros. And 3.405 times a million is going to make that a lot bigger of a number. So that's why we want to use the positive exponent. So for A, we changed 34,690 to 3.469 because we're trying to get the decimal, so there's a little number to the left. And we moved our decimal 4 places, so it's times 10 to the 4. So big number, so the exponent is positive.
for C, it's 3.9 times 10 to the negative second.
Because we're moving our decimal so that it's between the 3 and the 9, we only want one digit to the left of it, and it's a teeny tiny number, so we need to multiply by a negative exponent. For D, you get 7.22 times 10 to the negative 4th because you move the decimal so that it's between the 7 and the 2 twos. Because you want one number to the left of the decimal, and then it's times 10 to the negative 4 because it's a little number, and little numbers you get a negative exponent, and you move your decimal 4 places.